I have shared the board. Is it visible?
Yes, sir.
So in the previous class, I have covered up to this logic operation. And we know very well about the logical operations that these operations deals with the typically denoted by 1 means true or typically denoted by 0 false or yes or no. So for our purpose, this means binary images composed of foreground means 1 value pixels and background composed of 0 value pixels. So this is the truth table which is used to define the logical operators like AND operators, OR operator and NOT operator. So this table I have covered here. See this one in the previous class. Okay. So I have taken here variable A, variable B, and in the truth table it has 4 combination because there are 2 variables 0, 0, 1, 1, 0, 1, 0, 1. So for the ANDing operation, this is the output. For the ORing operation, this is the output. And for NOT, this is the output. I have drawn this here so that you can understand the OR operation and NOR operation at the same place. This is the ORing of A and B, and this is the just opposite of this OR gate, that is NOR. So this is the NORing of A and B at the same place. You can see. Just complement the output of OR to obtain the AND/OR operation. Similarly, this is the ANDing operation of A and B, and this is the NANDing operation of A and B. So this NAND and AND both are at the same place. The output of AND is complemented to obtain the NAND of two A and B inputs. This is the XOR and this is the XNOR operation. So XNOR output will be high if the inputs are different, and for the same inputs the output is 0. Suppose there are 0 for A and B, so we are getting 0. There are 1 and 1 for input A and input B. Both inputs are same, so output is 0. Now take the complement of this output for XNOR operation. Okay. So up to here, any student have any doubt?
No, sir.
Okay.
So can you start recording?
So I have not started recording. Okay, so in the previous class, I have covered logical operation with the help of this table. Also, I have drawn a complete table which contains the output for OR operation as well as NOR operation at the same place, and for AND operation and NAND operation at the same place. Similarly, for X operation as well as for XNOR operation at the same place. Is it visible?
Sir.
Okay.
Yes, sir.
So now see, it is a figure
Yes, sir.
containing some images in the first column as well as in the second column. So the first column and second column both are used to represent the input, and the third column, it is representing the output for a particular operation. For a particular operation. So you can see here this arrow, and above this arrow one operator or one operation is written here. It indicates that in the right side, it is the left side. In the right side, you are getting the output. Okay, these are the outputs, and these are the inputs. Suppose this is the input B1, this is the input B2, and we are applying AND operation. Then after that, in the output, we have obtained this type of image. So see, this figure shows the illustration of logical operations involving foreground, means white pixel. This is the foreground. Okay, white pixels, and they represented by 1 or ones, and background represents the binary. This is represented by zeros, and this is for the background. Is it clear? Okay, means each image has, this is the foreground and this is the background. Foreground is represented by ones and background is represented by zeros. Okay, and the dashed line are shown for reference only. Here, see, these are the reference lines which are shown here. And this, now let's start with the operation one by one. This is the B1, it is our input. So this one represents the ones and this represents the zeros. Now apply not operation. So this foreground will change into background. Okay, and this background will be converted into foreground. So see here, यहाँ पर आपका ये जीरो है, यहाँ पर आपका ये जीरो है, ये किस में कन्वर्ट हो जाएगा आपका ये, इट इज कन्वर्टेड इनटू 1, एंड ये आपका जो 1 है ये किस में कन्वर्टेड हो जाएगा आपका ये जीरो में. सो हियर 1 मीन्स यहाँ पर आपका कॉम्प्लीमेंट हो गया है ना. सो जस्ट टेक द कॉम्प्लीमेंट. So this part is complemented here. Okay, this is your foreground. It is converted into this. So this is the not operation. Now take input B1 and input B2 and apply AND operation. Then this is the dashed line which is indicating the input B1. This is the dashed line which is indicating the region input B1, region for the input B2. Now ending operation will be 1 only for if for the both 1 value. Otherwise, if we are getting 0 and 1, 0 and 1, so for this combination output is 0. So other points पर आप देख रहे होंगे यहाँ पर सभी जगह 0 है value. Okay, but this is the part only. You can understand. This is the part only where it has B1 has 1 as well as B2 has also 1. So the multiplication of 1 and 1 will give 1. That is why this is the 1. These all are 0. Is that clear? Hello?
Yes, sir.
Okay. ये फिगर आप भी समझ सकते हैं, but I think it will help you because you have study it in terms of simple Boolean algebra or in terms of truth table. But we will use this in the image processing so that you can more understand. Suppose this is the foreground, this is the background, this is the foreground. Okay, this is your black image, this is your white image. Okay. Suppose again it is your first image B1, this is your second image B2. Now apply or operation here. Or so ORing means यदि आपके पास में 0 और 1 है तब भी आपका 1 आएगा, 1 और 1 है तब भी 1 आपका आएगा, और 1 और 0 है तब भी आपका 1 आएगा। ओनली यू विल गेट फॉर 0 0 0। ओके, इज दैट क्लियर? सो सी दिस इज द आउटपुट। यहाँ पर सभी जगह 0 0 है तो सभी जगह 0 आया, यहाँ 1 1 है तो आपका ये 1 1 आ गया। सो दिस इज द आउटपुट फॉर the OR operation. Now AND NOT operation. This is the output for the AND NOT operation. ये आप B1 लेंगे, देन उसके बाद में ये आपका रहेगा B1, देन आपने क्या किया, B का कॉम्प्लीमेंट निकाला, दिस इज द B2, कॉम्प्लीमेंट ऑफ B2, तो ये आपका B2 है, नॉट ऑफ B2। देन उसके बाद में आपने उसकी एंडिंग ऑपरेशन की तो आपके पास में आउटपुट इस तरीके से आएगा। नाउ ये आपके पास में B1 इनपुट है, ये आपके पास में B2 इनपुट है, आपने इसका एक्स और ऑपरेशन परफॉर्म किया है। एक्स और ऑपरेशन परफॉर्म करने के लिए क्या है कि आपका 0 0 है तो 0 आएगा, 0 1 1 0 है तो इस केस में 1 आएगा, और 1 1 है तो आपका 0 आएगा। गेट क्लियर? सो यू विल गेट द रिजल्ट फॉर दिस एक्स और ऑपरेशन दिस। You can also perform by taking same image like X NOR operation, है ना, NAND operation and NOR operation. Okay, these you can perform. Is that clear?
Yes, sir.
Okay. Now take the screenshot of this page. Give Venn diagrams for the following expressions A, B, C, and D, and use Venn diagrams to prove the validity of the following expressions A, B, C, and D. This is the assignment for you. So have you taken the screenshot?
Yes, sir.
Okay, so this you have to do. Okay, I have posted both the question in the chat box, and students are required to do this assignment. Okay. I have posted in the chat box. Is it visible? Are you able to open?
Yes, sir.
Yes.
Yes, sir.
Now let's start the logical operations in more details. Okay. So logical operations are AND operation, NAND operation, or NOR, XNOR, and NOT. Logical operations are performed in a bitwise fashion. Okay, on the binary contents of the each pixel. Remember, okay, this one. We are dealing all the logical operations in terms of images. So the AND operation, XOR, and OR operators require two or more arguments, two or more than two. Okay, two or more than two operators. Whereas the NOT operator requires only one argument. Okay, तो NOT के केस में आपके लिए सिर्फ एक ही argument चाहिए. So here arguments, remember, okay, means inputs. Logical operators are generally derived from the Boolean algebra, a way of manipulating the truth table, truth values of the concept in the structure. The truth value of the concept in Boolean value can have just one of two possible values and give true or false. Now, and NAND operation. So let's see the and similarly the NAND operator typically takes two binary or integer gray level images as the input. If outputs a third image whose pixel values are just those of the first image, ended with the corresponding pixels from the second image. The operation is performed straightforward in a single pass. It is important that all the input pixel values being operated on have the same number of bits in them or unexpected things may happen. Okay. Now Boolean algebra allows you to represent things like see Boolean algebra allows you to represent things like Q, A and B. Suppose it is your A and it is your B and this is the output B. So AND operation I have covered it 0 0 0 0 1 1 0 1 and 0 0 1 1 के लिए after 0 रहेगा. Now this is the NAND operation. Take the complement of this output here. As can be seen, the output value of NAND are simply the inverse of the corresponding output value of the AND. Okay, is that clear? Image ANDing takes place pixel to pixel wise. In case where by is n, image of size equal to x, B will be the matrix of pixel map of by. Now this is the way A intersection B. Now A11, A12, A1n. This is the first row and column. Second row A21, A22, A2n. This is the first row. This is the second row. This is the n row. So AMN 1, AMN 2, AMN this one. So now take this is the suppose this is the image 1 and this is the image 2 B11, B12, B1n up to BNN. BMN, sorry, BMN. It is also AMN. Okay. So ending will be performed. Take the first element from image 1 and the second element from the image 2 at the corresponding position. Then right here simply A11 intersection now B11. Okay. So in this way perform it for all the elements or all the pixels. Then you will get the output. Now in case where by is a constant, B will be the matrix of same size as that of X containing a constant value by at all the elements. Now here change the operator. Here it is not union, it is everywhere. Okay. So again okay. Now this is the example. This is your image X, this is your image Y. Now perform the AND operation. Now you will get the output here. This is the output image. And these are the input images. Similarly, you can understand with the help of another example. This is the image 1. This is the image 2. This is the output image. Okay. Take X input, take Y input, and apply AND operation. You will get X and Y. This is the output image. Similarly, take image 1 take image 2, apply AND operation, you will get this type of image at the output. So this is about the AND operation. Now this we have applied on the gray image. No, this is not the gray image. This is the binary image. Okay, this is the binary image. Okay. Now take example. We have applied the operation here, where the pixel values in the input image are not simple one-bit numbers. So in this case, the AND operation is normally carried out individually on each corresponding bit in the pixel values in bitwise fashion. So the ending of the gray, this is not a binary, this is the gray. This is the gray image, and in the above, this was the binary. Okay, it is the example of binary image, and try to understand it with the help of gray image. Okay, so gray have some range of values. So the ending of grayscale images and intersection kind of effects is produced here. So it is your image 1. Okay, suppose it is image 1, it is image 2. So apply the AND operation here. AND operation, आपके पास में आउटपुट इस तरीके का आएगा. ओके, मीन्स जहां पर आपका व्हाइट है वहीं पर आपका इस तरीके का ऑपरेशन परफॉर्म करने के बाद आउटपुट में आएगा. Now you can also understand it with the help of MATLAB programs, and it will be covered in the lab section. Suppose now try to understand it in terms of some numbers. Okay, say suppose x, it is the pixel value of 4 bits. 4 bits means 1101. Okay, we have taken here 1101. Now it is a 4-bit value. ये आपका x1 है. And suppose we have taken another parameter, that is x2. It is 1010. It is also a 4-bit value. Okay. Now the most obvious application of AND is to compute the intersection of images. So apply the AND operation here. Apply the AND operation. So what will be the AND operation? It is 1 and 0. क्या होगा आपका? 1 and 0. Yes. Any student? Yes, 0. 0 and 1, again 0. 1 and 0, again 0. 1 and 1, it is 1. So this is the output, or it will be the output after applying the AND operation. So we illustrate this with an example where we want to detect those objects in a scene which did not move between two images. Okay, which are at the same pixel position in the first and the second image. Now see the application of this, how it is helpful. Is it visible? Okay, suppose if you want to highlight some special thing in your image. So this is the procedure, highlights the object. Suppose this is your image, and if you want to highlight this car only, so take mask and apply this A and B operation, you will get this car here. Now increase the intensity of this car, or we can say here we brighten this image by scaling it by a factor of 1.1. Okay, we have multiplied or increased the intensity or the brightness, and dim the original image using the scale factor of 0.8. And this is we have multiplied by 0.8 here. As written here 1.1 into C कर दिया आपने, this is the C output, and 0.8 into A. ओरिजिनल इमेज जो है आपकी, इसको आपने 0.8 से मल्टीप्लाई कर दिया, तो आपके पास में ये इमेज थोड़ा और डिम हो गया है. You have decreased the brightness. Now add this image, this image, this one and this one. Add two images, you will get this one. So in this figure you can see in this figure you have performed this operation to highlight this car only. Okay, this car only. So see in the same image it is highlighted. Okay, see the remaining other cars. Is that clear? Hello?
Yes, sir.
Clear है कि नहीं है? Means if you want to highlight some objects in a given image, okay, then you can highlight any object which you want in your image by following this procedure. Okay? Now take the logical operation, or operation and NOR operation. So the OR and similarly the NOR operator typically takes two binary, or we can say two gray level images as the input, and the output a third image whose pixel values are just those of the first image or with the corresponding pixel values from the second image. Okay, so the corresponding जो भी वैल्यू रहेंगी उस पर्टिकुलर पोजीशन की, उनका आपस में आप ORing करेंगे तो आपके पास में थर्ड इमेज बनकर आएगी. So a variation of this operator takes just a single input image and ORs each pixel with a specified constant value in order to produce the output image. Output values of NOR are simply the inverse of the corresponding output values of the OR. Okay, this is the same patient which I have taught in the previous for the and NOR operation, NAND operations. So suppose input A, it is the input B, and this is the ORing of A and B. So 0 0 gives 0, 0 1 1, 1 0 1, 1 1 1. These are the outputs. Now if you want to perform the NOR operation, so draw the truth table. Input A and B are the inputs and Q is the output. This is the inverse. Okay. Take the inverse of this. 0 ka 1, 0 1, 1 ka 0, 1 ka 0, 1 ka 0. Okay. Now similarly you can also understand it with the help of this array system. Suppose there are A11, A12, A1n, A21, A22, A2n. This is the for the first row, this is the for the second row, this is for the M row. So AM1, AM2, AMn. Okay, so this is up to here. This is the M cross n. Again, this is the M cross n size of the. So A है आपकी इमेज 1, A है आपकी इमेज 2. इन दोनों में आप यूनियन करेंगे तो आपके पास में ये पहला पोजीशन का जो एलिमेंट है, इसमें ये पहली पोजीशन का जो एलिमेंट है इसके बीच में आप ORing करेंगे और ORing करेंगे. ठीक है, you will perform this operator. So similarly, if you want to perform, suppose for this element only, so okay, you have to perform the AND OR operation for this and this. Is that clear? Now take this is the example. This is the example of binary image. This is the example of binary image. I have one image X, another image Y. Okay, now I have applied here OR operation. So after this, see this is the output. Okay. Now this is the second example. This is the image 1. This is the image 2. Apply or operator between the image 1 and image 2. Then this is the output. Is that clear? यहाँ पर इसकी वैल्यू क्या है 0, यहाँ पर इसकी वैल्यू क्या है 0, तो यहाँ पर क्या आएगी वैल्यू 0. ठीक है. Now apply this OR operation on the gray image. So the operation is performed straightforwardly in a single pass. It is important that all the input pixel values being operated on have the same number of bits in them, or unexpected things may happen. Okay, this you have to remember. It is important. Pixel values in the input images are not simple one-bit numbers. The OR operation is normally carried out individually on each corresponding bit in the pixel value in the bitwise fashion. So in the bitwise fashion means suppose you have image A, you have second image B, and perform the operation like OR operation. So take the pixel of this position, take the pixel of this position. Position must be same. Position must be same. And take the value of this point, take the value of this point and apply the OR operation you will get this type of structure, this type of image here. Similarly, see, it has this type of image here, and it has this type of image here. But in this output image, you are getting the combination of both this one as well as this one, because you are adding, you are ORing, or you are performing the logical OR operation on image A and on image B in a bitwise fashion. Is that clear? So you will get this is the output here. Yes. Now again, this is the same which I have taken for the NAND operation. So it is your suppose one variable x1. This is your another variable x2. It is a 4-bit. It is again a 4-bit. Then apply OR operator here. You will get this value. So check it. 1 or 0 is 1. 0 or 1 is 1. 1 or 0 is 1. 1 or 1 is 1. Okay, so this is the output. So ORing is usually safest when at least one of the images is binary. Okay, such that the pixel values are 000 and 111 only. But there is a problem with ORing other combinations of integers is that the output result can fluctuate wildly with a small change in the input values. For instance, suppose 127 ORed with 128 gives 255. 127 you can write it, 128 you can write it. Okay. Now take the ORing of this. Whereas 127 ORed with 126 gives 127. This is the 127. This is the 126. So OR करेंगे तो आपका आएगा 127. And जब MATLAB की बात करते हैं तो MATLAB has inbuilt function to perform the logic operations on the array. Suppose if we have two input images A and B, so there is a function bit end. Okay, so you can perform bit end between two images A and B by writing this bit end bracket के अंदर A, B. Okay, so here this is the output, and it is formed by the application of bitwise and operation on input A image and on input B image. Similarly, you can also perform the OR operation between the input image A and the input image B by writing bit OR operator, bit OR in the bracket A, B. Is that clear? Now see the and OR operations can be used to combine images for the special effect purpose also. This is the important thing. They are also used in masking operations. Okay, जो अभी आपको एक एग्जांपल दिया था मास्किंग वाला, whose goal is to extract or to enhance the region of interest from an image. इसका पर्पस क्या होता है कि हमको कोई एक पर्टिकुलर रीजन को एक्सट्रैक्ट करना है, या हमको रीजन ऑफ इंटरेस्ट जो है आपको उसको आपको फाइंड आउट करना है या डिटेक्ट करना है या एक्सट्रैक्ट करना है. Now both are very useful as a component of any complete large image processing application. Up to here, any student, if any student have any doubt, please you may ask. Yes. Arjun Sharma, Ayushin, Aman Raj, Divyansh Gupta, Kartikeya Pandey, Palak Chauhan, Pujan Mishra, Pushparaj Singh.
Yes, sir.
Yes,
Yes, sir.
Pushparaj. Pushparaj, up to here. If you have any doubt, then please you may ask.
No, sir.
समझ में आया ये सारी चीजें आपको?
Yes, sir.
आपने डीएलडी में ये सब स्टडी किया हुआ है या आपने फिजिक्स 11th में भी स्टडी किया हुआ हो? सिंपल लॉजिकल ऑपरेटर्स जो रहते हैं, बट दीज आर वेरी यूजफुल इन द इमेज प्रोसेसिंग. ओके, इसको आपको इमेज प्रोसेसिंग में यूजिंग मैटलैब परफॉर्म करके चेक करना है आपको, तब इस चीज पर आपको और इंटरेस्ट आएगा, है ना? ओके, so now I am starting the logical XOR and XNOR operation. So the XOR function is only true if just one and only one of the input value is true, or and false otherwise. So remember the statement. It is only true if just one and only one of the input value is true. Okay? यदि आपके पास में सपोज यहाँ पर n इनपुट्स हैं, ओके, सभी की वैल्यू 0 0 है और एक भी इनपुट यदि आपका 1 आएगा और इसके बीच में आप यदि आप XORing करेंगे तो क्या होगा? आपका आउटपुट क्या हो जाएगा? 1 आ जाएगा, मीन्स ट्रू. दैट क्लियर? XOR stands for exclusive OR. Exclusive OR. As can be seen, the output values of the XNOR are simply the inverse of the corresponding output values of the XOR. And for the XNOR operation, it is the inverse of the corresponding outputs of the XOR. XOR का जो भी आउटपुट है उसका आप इनवर्स लेंगे, आपको XNOR का आउटपुट मिलेगा. Now the XOR and similarly the XNOR operator typically takes two or more binary or gray level images as the input. You can take two or more images. Images may be binary. Then in case of two images inputs, it results an image whose pixel values are computed by applying XORing operation. You will get one output here. Now the pixel values in the output image is equal to the corresponding pixel value in the first image XOR with the corresponding pixel values from the second image. तो आउटपुट इमेज में जो भी आपकी पिक्सल वैल्यू आएगी किसी पर्टिकुलर पोजीशन पे, वो आपके दो इमेज हैं, उस दो इमेज के इस पर्टिकुलर पोजीशन की जो पिक्सल की वैल्यू है उसके बीच में आप XOR ऑपरेशन परफॉर्म करेंगे, उसके बाद में जो आउटपुट आएगा वो यहाँ पर अवेलेबल है. Okay, and a variation of this operator takes a single input image and XOR is pixel value with a specified constant value in order to produce the output image. And again here you have also the same thing. You have to perform this operation straightforwardly in a single pass. Okay, it is important that all the input pixel values being operated on have the same number of bits in them, or unexpected things may happen. Okay, so there must be same number of bits. Is that clear? Hello.
Yes, sir.
Yes, sir.
Now see, this is the truth table. Input A, input B, and this is the output for XOR operation here. XOR operator. So 1 1 is 0 and 1 1 is 1. So either of the input is high or true, output is true. Is that clear or high? X नॉर का करना है तो take the inverse of this one. 0 का 1, 1 1 का 0 0 here and 0 का 1. This is the output. Okay. Now similarly you can understand it with the help of this array. Okay, so this is your A and it is your B. Apply this operator on pixel wise. This is the pixel. This is the again pixel. It is belong to A and it is belong to B. Now at the same position, this is the position number 1. You will get the output after applying this operator XOR. Okay, take it. Whatever will be the value, write here at position number 1. Suppose it is position number 1, it is again position number 1, so it is again position number 1. It is correspond to the output image. Is that clear? Similarly, you can find out for any value. Suppose for this, you have to write here. Similarly, for this one, you will write here this one. Okay. Now this is the example. So in this example, I have taken binary image. This is image X, this is image Y, and we have taken this XOR operator, exclusive OR gate, and perform the operation according to the truth table. Okay, either of the input is true, output is true for the corresponding bit. This is the output corresponding. Now again, it is input A, not A because it is B1. So it is input B1. It is input B2. Apply this XOR operator here. You will get this type of output here. Clear है? साहिल सोनी, सुभाष चंद्र बोस, वैभव कुमार सिंह, वैष्णवी वर्मा.
Yes, sir, clear.
क्लियर है बेटा? एनी स्टूडेंट? कोई डाउट है तो आप पूछ सकते हैं. Now see, this is the example for gray image. Now why I have taken these examples, I have already covered it in the logical operators, because we have to deal with the image. Now the logical operations we have to perform on images. So the procedure is, आप यहाँ पर पिक्सल वाइज आप ऑपरेटर को अप्लाई करेंगे तो आपका करस्पॉन्डिंग जो पोजीशन है उस पर पिक्सल वाइज ऑपरेटर का आउटपुट आपके पास में अवेलेबल होगा. ऑरिंग होकर या एक्सऑरिंग होकर या एंडिंग होकर या लैंडिंग होकर. इट डिपेंड्स ऑन द ऑपरेटर. नाउ सी, दिस इज द ब्लैक एंड दिस इज द व्हाइट. Only 0 and 1. That is why it is the binary image. But here it has some values between 0 and 1 also. Okay, 0 and 1. It is suppose pure white means 1. It is suppose pure 0, black means 0. But these are the sets of gray where the value is neither 0 nor 1. Am I right? So this is input image A, input image B. Now apply this operator X or here. Means either 0 either A और B में यदि आपका कोई भी यदि एक ट्रू होगा या मान लीजिए 1 होगा तो आपका आउटपुट क्या हो जाएगा? 1 हो जाएगा. Okay, so you can see You can check it here. बट यहाँ पर 0 और 1 की बात नहीं करेंगे, यहाँ पर तो आपकी डिफरेंट वैल्यूज है बिटवीन 0 एंड 1. सो अकॉर्डिंग टू दैट यू विल गेट हियर द आउटपुट. Okay. Now see here written this thing. Pixel value in the input image are not simple 1-bit number. The XOR operation is normally carried out individually on each corresponding bit in the pixel values in a bitwise fashion. यहाँ के वैल्यू के साथ में जो corresponding आउटपुट है वो यहाँ आएगा. इस पर्टिकुलर एरिया में और इस पर्टिकुलर एरिया में यदि इस पोजीशन की बात करेंगे तो आपके पास में आउटपुट यहाँ पर आएगा. Okay. Now try to understand it with the help of some numbers. So it is our x1 1101, x2 1010, and the XOR operation. So right here कोई भी एक इनपुट यदि हाई होता है तो आउटपुट हाई रहेगा. 1 और 0 में 1 है, यहाँ पर है तो आंसर आएगा 1. यहाँ पर भी आपका आंसर आएगा 1. यहाँ पर भी आपका आंसर आएगा 1. यहाँ पर ये वैल्यू दोनों सेम है, इनपुट्स आर सेम, तो आपके पास आंसर आएगा 0. Now the XOR operation is often used to highlight the differences between the two monochrome images. Okay. The purpose of this is to highlight the differences between the two monochrome images. It is therefore equivalent to calculating the absolute difference between the two images. Whatever I have written here, you can prove, you can justify this with the help of one example using MATLAB program. Now this is the XOR and XNOR are often used as a subcomponent of more complex image processing tasks. XOR has the interesting property that if B XOR A with the B to get Q, then the bit of Q are the same as A, where the corresponding bit from B is 0. But they are of the opposite value, where the corresponding bit from B is 1. So for this reason, B could be thrown off as a bit reversal mask. You can understand it better with the help of digital image processing method. Okay. Here the operator is symmetric, so we could just as well have treated A as the mask and B as the original. Now extending this idea to the image, if it is common to see an add bit, now take add bit XOR image mask containing only the pixel values 0 and 255. This is 0 and this is the 1 range. When this is XOR pixel by pixel with an original image, it reverses the bits of the pixel values where the mask is 255 and leaves them as they are where the mask is 0. So the pixel with reversed bit normally stand out against their original color, and so this technique is often used to produce a cursor that is visible against an arbitrary colored background. The other advantage of the using XOR like this is that to undo the process, for instance, when cursor moves away, it is only necessary to repeat the XOR using the same mask, and all the flipped pixels will become unflipped. Note that the flipped pixels are not always visible against their unflipped color. Light pixels become dark pixels and dark pixels become light pixels, but middling gray pixels become middling gray pixels. So I think it is completed. So up to here, if any student have any doubt, then please you may ask. Any doubt?
No, sir.
So those who have joined today's class late, just see what I have covered. So I have started with this diagram. Then I have given this assignment which you have to complete. Then I have started the logical operations as you are able to see in this slide. Then I started with and operator to table. This is the pixel, to represent the pixel wise operation. These are the two examples for the not the gray image. It is the this binary image. It is the binary image. And see the example for the gray image. This is the example of gray image. And this we have performed bitwise operation. And so you can practice whether the portion may be in this form, the portion may be in this form gray image, or maybe in this form binary. Okay. Now this is the application. If you want to highlight some objects, like I want to highlight this car only in this image. So this is the way there is a mask. Then we apply operator between the image and the mask. Then we will get this output only. Then we will increase the intensity, okay, or the brightness, and we will decrease the brightness of this input image, original image. Then after adding these two, we will get this type of image. Now, then logical OR operator. So similarly, definitions, truth table, and the representation for array. This is again the binary image example, the gray image examples. This is the in terms of pixels, and this is the operators which are available in the MATLAB. After that, I have completed the XOR and XNOR operation with the help of truth tables, with the help of this matrix or array, and with the help of binary images, with the help of gray images. These are the two types of examples. Also, I have taken examples in terms of pixel values. Okay, so you can understand it. Then next I will cover in the next class. So up to here, if any student have any doubt, please you may ask. किसी स्टूडेंट को कोई डाउट है तो पूछ सकते हो, है ना? अभिषेक आनंद,
यस सर।
जो असाइनमेंट लास्ट या प्रीवियस क्लासेस में आपको दिए हैं, हैव यू कंप्लीटेड?
सर स्टार्ट कर दिया है सर, कुछ बाकी है।
ओके, अभिषेक कुमार,
यस सर।
कंप्लीट कर लिया है आपने?
यस सर।
आयुष सिंह, इशिका सिन्हा, और मैंने आपको लैब का भी टास्क दिया था कि यू हैव टू कंप्लीट योर प्रैक्टिकल फाइल, है ना? तो आई थिंक कंप्लीट कर लिया होगा आपने। ओके, कोई डाउट नहीं है, क्लास एंड करें? किसी स्टूडेंट को कोई डाउट है? Okay, you may leave the class.
Thank you, sir.
Thank you.